All right, so we're on to graphing sine and cosine functions, but we're going to talk about shifting them up, down, and left, right today. The up, down is not bad at all. The left, right is very tricky. So the idea today, and again, we're using this setup over here, is that like other functions, trig functions can be translated to the left or right. H represents a horizontal shift, which in trig is called a phase shift. And K represents a vertical shift, up or down. So K would be a shift up. If it's negative, it's down. That's not too complicated. You guys need to stop with the toenails on the floor. Sorry, that's the dogs. All right, a phase shift, and I want to give you an example here. If it said like x plus pi over 2, this would actually be a shift left pi over 2. And if it said x minus 4, okay, it doesn't always have a pi, it would be a shift to the right 4. All right. Remember, it's always the opposite when it's inside the parentheses there. Shifting a graph vertically creates a new horizontal axis called the midline. And so this plus 4 back here shifted this whole thing up. Here's 1, 2, 3, 4. So here's the new midline at y equals 4. All right, sorry, I had to deal with the dogs. So the midline is up here for this one at y equals 4 because of this vertical shift up 4. This is the reference line about which it oscillates, meaning it goes above and below. The equation for the midline is just y equals k, whatever k was from this guy. It could be sine or cosine. And I don't like that they don't put more parentheses here, but okay. So we're going to try one of these. This one is a little weird because it has a 3 halves out here, but we'll deal with it. This means the amplitude is 3 halves or 1.5. Just to make it easier for writing the quarter points, we're going to do 1.5. The period, B is just 1, so the period is just 2 pi. The phase shift, we don't have one yet, doesn't go left or right, but there's a k value of plus 3. So that's up 3, which makes the midline y equals 3. So the midline is up here at y equals 3, and I always draw that as a dotted line. And then what I usually do is I take my amplitude, I go up 1.5, which would be 4.5, and now I draw myself a little boundary. That's where it's going to max out at 4.5. And then I go down 1.5 from 3, midline down 1.5. So that would be 1.5. Because 3 is in the middle, and you go up 1.5, you're at 4.5, you go down 1.5, you are at 1.5. Okay. Then this is a sine graph. So it starts at the midline here, and it goes this shape, up, down like that. Now this one had no period change, so the period is 2 pi, so it's going to finish there, halfway in between, and halfway in between there. Or remember, you take the period and you divide it by 4 to get the quarter points. So it's pi over 2 plus another pi over 2 plus another pi over 2 plus another pi over 2. So we had, this one would be 0 and up 3. The next one would be over pi over 2, but it's at 4.5. The next one is over another pi over 2, which reduces to pi. And that one's back at the midline. The next one's over another, which is 3 pi over 2. And that one's at the bottom, which was 1.5. And then you're back at the midline, out at 2 pi. Now you could draw this, go in the other direction as well. Okay. So a little trickiness, but no phase shift yet. Okay. This is also a vertical change. The A value is 1, but it's the same as 1/2 theta. And since there's no parentheses here, the -4 is a vertical change, so you might do this, okay? Amplitude is 1, B is 1/2, which makes the period 2 pi divided by 1/2, or 4 pi. And the vertical shift is down 4 because of the -4 on the back, which makes the midline -4. Y equals -4. So if I graph this, I'm going to put my x-axis up a little bit because I'm supposed to go down to -4. That's my midline. And the amplitude is 1, so I'm only going up 1 to -3 and down 1 to -5. It is a cosine graph. So it starts at the max and does this shape, and it has no phase shift, so it's going to start here. It's going to go to the midline, down, back to the midline, and up. Now I like to draw it and then worry about putting in these quarter points. The quarter points are the period divided by 4. So we're really fortunate on this one. The quarter points are just every pi. So this is 0, -3, and then a quarter of the graph later would be pi, and it's down to -4, and another pi would be 2 pi, and it's down to -5, another pi would be 3 pi, and it's down to -4, and then 4 pi, which was the period, is where it finishes, and it's back at the max, which was -3. So you could put pi, 2 pi, 3 pi, and 4 pi if you wanted up there. All right, that's why I like drawing them freehand. Okay. Number 7 is also only a vertical shift. This shift is up 1. The period, the B is 1, so the period is just 2 pi. The shape is a negative sign, so it's going to start and go down first because of the negative, but the amplitude is still just 3. The negative is not the amplitude. Okay, so it's shifted up 1, so I'm going to move my x-axis down a little bit, and I'm going to shift up 1 for my midline. And then above that, it goes 3. So that would be the maximums are going to occur at 4. Again, you can put a little dotted line there if you want. And 3 below 1, you start 1, go down to 0, down to -1, down to -2. The minimums are going to occur down here at -2. All right, so it was going to start at the midline because it's a sine graph and it's supposed to go down first. It goes down to -2 and then back up. and then it goes up 3 to positive 4 and back to the midline of 1. All right, the period is supposed to finish at is 2 pi. So the quarter points are 2 pi over 4 or pi over 2. And you just keep adding on pi over 2. So the first one here would be pi over 2. Then 2 pi over 2's, which would be pi. Then 3 pi over 2's. And then 4 pi over 2's, which would be 2 pi, and it's back at the midline of 1. Okay, so vertical shifts I don't think are that bad. Quarter points, as always, can be tricky. All right, so the rule is to graph this, you find the period of the function and you divide it by 4. But then when there's a phase shift, which is coming up here, you add that period divided by 4 to the left endpoint of the interval. So you take the shift, left or right, and then you start adding the period over 4, and then you add another period over 4, and another period over 4, whatever that amount is. Now, you have two choices here. You can use your calculator and leave off the pi, okay? Or you can get a common denominator and just use fractions and your brain. But you have to give me fractions. You cannot give me decimals. All right. This just shows that sine and cosine are just phase shifts of each other. We're going to go with this question. All right, this is a big old nasty one. It has lots of stuff going on. This is as complicated as I would ever give you to graph. It has a amplitude. Now A is -2, but the amplitude is, remember, the absolute value of that, so it's 2. The period B is 1, so the period is still just 2 pi. The phase shift minus actually moves it to the right, a pi over 3. And the vertical shift on the back is up 1, so the midline is at y equals 1. Now, we can graph it first, or we can talk about the domain and range. The range left to right is always just -infinity to infinity. But remember, domain is highest and lowest y value. Well, if this was shifted up 1, and then we're going to go an amplitude of 2 above that and 2 below that, 1 plus 2 will make the maximums at 3. 1 minus 2 will make the minimums at -1. So the domain, I have this backwards. That was very helpful. Okay, let's see. Well, let me just move this. The range, the domain left to right is -infinity to infinity. But the range up and down, sorry about that, guys, is the bottom is -1 and the top is 3. But we could graph it first and that might make more sense to you. All right, I'm going to go down just a little bit, and then I'm going to draw our vertical shift up 1. So this is the line y equals 1, and that's going to be our midline. Then the amplitude of 2 means up 2 from that would be 3, so that's where our maximum is going to occur. 2 below that, +1, would be -1, and that's where our minimums are going to occur. So that explains the range goes from -1 to 3. Now, this has shifted to the right pi over 3, so it's going to start over here. Oh my goodness, and it's a negative cosine, so it's going to start at its minimum, go up, and go back to the minimum. So I don't know where that's going to be. I'm just going to start over here somewhere, start at the minimum, midline, maximum, back to the midline, minimum. Okay, so this was a shift to the right pi over 3, and it was down at the minimum. Now we got to figure out what to label all the rest of these points. So we take that shift right, and we add the period divided by 4. Now, this is where you could use your calculator. You could say, you don't type the pi though, because that'll give you decimals and you don't want decimals. Okay. You could say I have 1/3 and I'm supposed to add 2/4, and then do your math, enter, enter. You have 5/6 are going to be the first quarter point. Then you're supposed to add another 2/4. And you don't have to hit enter, you could just hit math, enter, enter. And that's going to be 4/3. Or then you're going to add another 2/4. And actually, if you keep hitting enter, if you've done it the way I have, it'll give them to you. But, so after 4/3, we had 11/6. Remember, we left out the pi. And then after, we need one more. So after 11/6, it had 7/3. Okay. Now, I would really like to talk you through this. Without the calculator. If you change these to a common denominator of 6, this one becomes 2/6. Everybody good? 1/3 became 2/6. Oh, common denominator is not 6? Well, actually it is, because this reduces, okay, to pi over 2. And then the pi over 2, when you multiply by 3, would be 3/6. Okay, so they have a common denominator now. This was the phase shift, and this is the quarter points that we're adding on. And then we're supposed to keep adding it. So we ended up starting at 2/6. We added 3 was 5/6. We added 3 was 8/6. We added 3 was 11/6. We added 3 was 14/6. Then those just reduce. The first one is pi over 3. The second one doesn't reduce, 5/6. The third one, 8/6, reduces. The next one, 11/6, does not reduce. And the last one, 14/6, 7/3, comma, -1. It's supposed to be a -1. Okay. Now, somebody's going to say, well, it was supposed to have a period of 2 pi. This is super important, guys. That means if it started at 0, it would finish at 2 pi. But because this shifted to the right 1/3, it finishes, 1/3 of a pi, it finishes at 2 1/3 pi. 7/3, 3 goes into 7 twice with 1 left over, is 2 1/3 pi, because it shifted to the right 1/3 and it took it 2 pi to finish. Okay, the period is not where it finishes, it's how long until it finishes. So when we have a phase shift, that messes with things. All right, what we're going to do on these next ones is I'm just going to talk through them without actually graphing them, because then we're going to do the practice together where we graph them. So here the amplitude is 3, the B value is just 1, so the period would be 2 pi. It has no added shift on the back, so there's no vertical shift. The plus pi is actually a shift left pi. Now, let's talk about how to find the quarter points. You would say it shifted left pi, okay? And then you would say plus the period over 4. And it's always over 4 because it's quarter points. All right, so if you made this a common denominator, this would be 4/4. So you would start at negative pi, and then you would add, which was a negative 4/4. You would add 2 pi. You get negative 2/4, or negative pi over 2. Then you would add, oh, I shouldn't reduce, that's going to confuse somebody. So we started at negative 4/4. Then we added 2. We add another 2. We add another 2. And we add another 2. And then you can reduce those. So we have negative pi over 2, 0, pi over 2, and pi as our quarter points. And they would be, because it's a sine, it starts at the midline. So the first one would be at 0, the next one will be up at 3, the next one will be back at 0. So this would actually go through 0, 0. Graphed it, because it's shifted all the way over here to negative pi, so it finishes at positive pi. All right. This one is amplitude of 1. B is 1, so the period is still 2 pi. It has a vertical shift up 2 and a phase shift to the right, pi over 4. So it is going to start at pi over 4 for the quarter points. And then you are going to keep adding the period over 4. So if we add 2 pi over 4 once, we get 3 pi over 4. Add another 2 pi over 4. These don't reduce, this is handy. Add another 2 pi over 4, add another 2 pi over 4. Because, remember, this is 1/4 that it shifted to the right, and 9/4 is 2 1/4 because it shifted over, so it doesn't finish until 2 pi later, which is 2 1/4. All right, if you wanted me to do a rough sketch, it shifted, let's see, up 2, I forgot to write that down. And the amplitude, it was shifted to the right pi over 4, but it's a cosine graph, so it would start 1 unit above, this is 2, so 1 unit above that would be 3, 1 unit below that would be 1. It would start over here to the right pi over 4. And then it would go so it would have pi over 4, 3 pi over 4 would be right here, and that would be at the midline of 2. This would be at the minimum, so it would be 5 pi over 4, 1. Then we'd have 7 pi over 4, 2, and 9 pi over 4, 3. Okay, you don't have to draw the sketches if you don't want to. Obviously, it's your notes, do what you want. All right. I'm going to try, let's see, amplitude is 3, period is 2 pi, vertical shift is up 1, phase shift is left, pi over 2. So we're starting at negative pi over 2 because of the left, and then we're going to add the quarter points, which is the period divided by 4. Now, to get a common denominator, this one reduces, so this is really just pi over 2. So it's going to start at negative pi over 2, and you're going to add a pi over 2. You're going to add another pi over 2, another pi over 2, which will be 2 pi over 2, which will be pi, and another pi over 2. All right, if you were graphing it, if this is 0, it starts up 1. It's a sine. It shifted to the left. The next quarter point, let's see, amplitude of 3 above there would be 4. 3 below there would be negative 2. Starts at the midline. And finishes back at 3 pi over 2, 1. Okay, we have negative pi over 2, 0. This would be pi over 2, 1. At pi, it's down at negative 2. All right, one without a phase shift. So much nicer without a phase shift, but this is going to have a period change that's kind of ugly. So the amplitude is 1, but the period is 2 pi over 3. The vertical shift is down 2, and it has no phase shift. So down 2 means we are at negative 2, and it only goes 1 unit above and below that. So it goes from negative 1 to negative 3. It has no phase shift left or right, so it starts like a regular cosine graph at its maximum here. Oh, I went a little too far down, but just pretend that's at negative 3. All right, but when you have a period of 2 pi over 3, you have to divide that by 4 to find the quarter points, which would become 2 pi over 3 times 1/4, or 2 pi over 12, which is really pi over 6. So this would be pi over 6. This would be 2 pi over 6. This would be 3 pi over 6, which reduces. And this would be 4 pi over 6, which reduces to 2/3, which we were supposed to have a period because there was no phase shift. It should finish at 2 pi over 3. No, I didn't. All right. Now, this is writing a sine graph, and it does say specifically sine. The first one is funky. It has a period of 4. It does not say a period of 4 pi. So we're going to talk about the fact that a period is usually 2 pi divided by b. But if we have b, then you take 2 pi divided by the period to find the b value. They are reciprocal relationships. Sorry about the dog issues. Okay, so when they tell us the period is 4 here, what goes into our equation has to be 2 pi divided by 4, or pi over 2. So our equation is going to be amplitude of 2 sine pi over 2, phase shift to the right 1/2 makes it minus, and a vertical shift up 4. Now let me go through that one more time, and that is because a normal period of 2 pi divided by pi over 2 would become 4, which would be a period of plain old 4, which is what they wanted, which goes much better with a shift to the right 1/2, because you don't want something that has pi's when you're shifting only 1/2 over. All right, this one is a little bit easier. The amplitude is 1.2. The period is not listed, so we're going to assume it's just 2 pi. So therefore our b is just 1. So we have the sine of, to the right 3 pi over 2 would be minus, and a vertical shift of up 1. Okay, not going to do a lot with writing equations yet. So the assignment is to go through and do the evens on this worksheet. I'm going to do the odds. I'm going to go kind of fast, so you can pause or stop as needed. But your assignment is to do the evens. So up 1 is here. Not a big fan because it gives us graph paper, but we're going to make it work. The period is 2 pi. So amplitude is 4, so it goes 4 units above 1, which means the maximums all happen at 5. The minimums happen 4 units below this. Vertical shift up 1. So we have 1 plus 4, the maxes are at 5, and 1 minus 4 is negative 3, and that's where the mins are. No phase shift, thank goodness. So it is a normal cosine, it starts here. The period is 2 pi, so the quarter points happen every 2 pi over 4, which is pi over 2, and so it's just going to go pi over 2, 2 pi over 2, which is pi, 3 pi over 2, another 2 pi, another pi over 2 would be 4 pi over 2s, or 2 pi. So there we go. So the ordered pairs are 0, 5, pi over 2, 1, pi, negative 3, 3 pi over 2, 1, and 2 pi, 5. If you notice, the x's are going up by pi over 2's. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And the y goes max, midline, min, midline, max. Okay? Number 3, this is supposed to say negative 1 minus sine 4 theta. This is a vertical shift. We could have also written this as, okay, so this is a shift down 1. The midline is y equals negative 1. Okay. They nicely gave us graph paper that counted by 4s here, pi over 4s. Our period is 2 pi divided by 4 because of this 4. So the period is really a pi over 2. Oh. So when we divide that by 4, we get pi over 8. They didn't really give us enough, did they? So we're going to count by pi over 8s. So it starts at pi over, no, it doesn't have a shift. It starts at 0. And then we're going to add pi over 8s. 2 pi over 8, 3 pi over 8, 4 pi over 8. So it's going to finish at 4 pi over 8, which is pi over 2, which was the period right here. Because this reduced, remember? All right. It is down 1 with an amplitude of 1. So it's going to go up to here and down to here. The vertical shift midline was y equals negative 1. I guess I already wrote that once. All right, but the other thing is it's a negative sine graph, so it needs to start at the midline and go down first. So it's going to start here, but it has to finish by pi over 2. So it's going to go down, midline, up, midline. Down, midline, up, midline. All right, not a fan of this graph paper. So it started at, let's do this. It started at 0, negative 1. Then it went to pi over 8, down to negative 2. And it's back at the midline, which was over another 4th or 8th, which would be 2 pi over 8 or pi over 4, and it's back at the midline. Another 1/8 would be 3 pi over 8, and it's up at the top, which is 0. Then 4 pi over 8 or pi over 2, it's back at the midline, which is at negative 1. All right, so these are 8s, 0, 1/8, 2/8, 3/8, 4/8. They're just reduced. And then you have midline, bottom, midline, top, midline, because it was a negative sign. Whew, much better when we don't have a graph, in my opinion. All right, so it goes up to and that's the midline. And it goes an amplitude of 4. So it goes 4 above that, which would be 3, 4, 5, 6. And 4 below 2, which would be down to -2. No phase shift. Oof, that was my calculator. Okay. It is a sine graph, so it starts at the midline, goes maximum, midline, minimum, midline. So this was at 0, 2. Then it went over and up to 6. This one is over and back at 2. This one is, whoops, over, which we haven't discussed yet, and down at -2. And this one is over and up at 2 again. All right, now the period is 2 pi. B was 2 in the equation right there. So 2 pi over 2 makes the period pi. But our quarter points occur at 1/4 of that. So we have a pi over 4, another pi over 4, which would reduce to pi over 2, another pi over 4, and another pi over 4, which is pi, which is what we were supposed to finish at since it had no phase shift. All right, I hope I covered all that. Sorry, trying to make my phone so it doesn't beep again, and I can't. All right, couple more. Ugh, phase shift. Okay, this is a shift left, 3 pi over 4. So it is going to start over here at -3 pi over 4. It is a cosine graph with no vertical shift. So it's going to start at its maximum and go like this. The amplitude is 4, and because it has no vertical shift, it's just going to go from 4 to -4. Okay, it's a little important though that I figure out my quarter points this time rather than sketch it, because I don't know how many quarter points fall on either side of this axis. So remember, it's period divided by 4, starting with your shift. So my shift is left 3 pi over 4, and my period is 2 pi over 4. Now these nicely have a common denominator. So the first one was -3 pi over 4. When I add 2 to that, I get -1 pi over 4. If I add 2/4 to that, I get +1/4. If I add 2/4 to that, I get +3/4. And one more time, +5/4. Did I need that many? Let's see. Okay, cosine starts at the maximum. The next one is -pi over 4, and that would be a midline. Then +pi over 4 would be the minimum. Back at the midline over here at 3 pi over 4. Because, guys, halfway in between here would be a pi over 2, so I'm trying to space these out. You don't have to list that. I don't really care. And then it ends at 5 pi over 4. We did need that last one. Because from here to here is, this distance is 3 pi over 4s, and this distance is 5 pi over 4s. So that's a total distance of 8 pi over 4s, or 2 pi, from where it started to where it ended. All right, so we had -3 pi over 4, 4. We had -pi over 4, 0. We had pi over 4, -4, 3 pi over 4, 0, and 5 pi over 4, 4. All right, these are not that fun, huh? This is the hardest day, I promise. All right, last one. Please be the last one. Oh, good. I think it is, right? Oh, no, it's not. Okay. Should have made this 2 videos, obviously. This is a phase shift left, pi over 4. I'm going to go a little faster. So it's starting over here, left, pi over 4. Negative pi over 4. It is a negative sine graph. So it starts at the middle and it goes down like this. Okay. So we have a negative pi over 4, 0. And the amplitude is 3, so it goes from a negative 3 to a positive 3 because there's no vertical shift. Now, from negative pi over 4, the period is 2 pi because the b value is just 1, so we're supposed to add the period divided by 4, which would make the next quarter point happen at 1 pi over 4. And then if you add another 2 pi over 4, you'd be at 3 pi over 4. If you add another 2 pi over 4, you'd be at 5 pi over 4. Add another 2 pi over 4, and you'd be at 7 pi over 4. Now, so if we had 7 pi over 4 back to 0, and another 1 pi over 4 to the left, that's a total of 8 pi over 4s from beginning to end, which is 2 pi. All right, now they get nasty because they have both a phase shift and a vertical shift. And I'm probably not going to ask you to do this on a quiz, but at least there's no period change. All right, so this one has a midline at negative 2. Stop. The amplitude is 3, so it goes above that 3 to 1 and below that 3 to negative 5. Right? That's a distance of 6, which is 3 above, 3 below, negative 2. Okay, then we have a shift to the left, pi over 4. And because the period is 2 pi, we're going to add 2 pi divided by 4 for our quarter points. So our next quarter point is 1 pi over 4. When we add 2 more pi over 4s, we'll get 3 pi over 4. 2 more would be 5 pi over 4. Okay? So 1 pi over 4. 3 pi over 4s, because we added 2 of those. 5 pi over 4, 7 pi over 4. Okay, now it's a cosine, so it starts at its maximum. Get another color here. It's going to start here at the max, then it's going to be at the middle, then it's going to be at the min, back at the middle, and at the max. So we have negative pi over 4, 1. Pi over 4, negative 2, 3 pi over 4, negative 5, 5 pi over 4, negative 2, the middle again, and then 7 pi over 4, it's up at the max, which is 1. Okay, are we having fun yet? Please tell me I'm finally on the last one. All right. One more time, we can do this. It is shifted up to has an amplitude of 4. So it'll go up to 6. Down 4 would be at negative 2. And up here are all the maximums, and they are at 6. So we took care of this 4, that's the amplitude, and the midline was at y equals 2 because the vertical shift was up 2. All right, this is actually a phase shift to the right, 3 pi over 4. So it's going to start over here. It's a sine, so it's going to start the midline, and that's going to be 3 pi over 4. But it's going to go up, back to the midline, down, and back to the midline. Now we got to figure out these points. Okay, we're in pretty good shape because the period is 2 pi. We had a phase shift of 3 pi over 4. We're supposed to add the period divided by 4. So the next one is 5/4. And then we're supposed to add another period divided by 4. And another period divided by 4. And another period divided by 4. Now, I just want to show you that if you take 11 and subtract off 3, that is a distance of 8 pi over 4s, and 8 pi over 4s is 2 pi. So this, from the start to the finish, is a length of 2 pi. All right, so let's just put in, this one's up at 6, this one is at 2, this one is down at -2, and this one is back at 2. All right, we survived. I'm sorry it's long, it's complicated, but please do the evens and we can go over questions in class.